I am a Doctor Who fan. But even though she is the Doctor,
The original, you might say.
I am also a Doctor in physics. And that puts me in a difficult situation. As a Doctor Who fan, I like the plots, the travels the Doctor takes, the science tools she uses, the explanations about the universe, the TARDIS, of course. But from a Doctor in physics perspective, how can I explain traveling in the TARDIS? How can I explain the sonic screwdriver? How can I explain so many things that appear in the show? Well, I have already explained some of the physics in Doctor Who in other YouTube videos. There are also some interesting books precisely about the science in Doctor Who. Today, let me go to one of the most recent episodes of the show, with a platoon of Jadoon near the moon. In this episode, we see a couple of weird things that are hard to explain. The first one is the teleportation that we are seeing more and more in the show. Teleportation as such is something we can't allow, something there is no way to explain with the science we have. From what we see, they just disintegrate people or a platoon of Jadoon and instantly integrate them back at another point in the universe. If you were to do this, you would need the information of position and velocities of all the atoms in the body of, let's say, Graham.
I'm going to say you that. That's the worst cake I've ever seen.
So that we know how to reintegrate him back. Well, that is not just technologically impossible, but also physically impossible. The number of atoms in a person is of the order of 10 to the power of 28. That is a 1 followed by 28 zeros. For each position, we need 3 numbers, 3 coordinates, and for each velocity, 3 numbers. That makes it 6 times 10 to the power of 28. That is something we cannot compute. That is something we cannot store in all the computers we have on the entire planet. But another question you might be asking is, how are we going to measure all those positions and velocities of all those particles of Graham? Or probably you are asking, how are the atoms going to be rearranged after the teleportation? Well, here we've got a better question. Is it even possible to measure with high accuracy and simultaneously the position and velocity of a single particle? The answer is no, it is not. One of the most bizarre and disturbing aspects of quantum mechanics is the fact that we cannot measure both position and velocity simultaneously. As a matter of fact, the particle has not even well defined those parameters at once. The particle is like a cloud of probability that has not well defined simultaneously position and velocity. If you measure one, let's say position will then become clearly defined and the particle will have that position. But on the other hand, the uncertainty in the velocity increases widely. The velocity becomes very undefined. This weirdness is inherent in quantum mechanics, to how nature behaves at the scale of the elementary particles and atoms. Well, you might think that the bodies have not been disintegrated and reintegrated, they just traveled from spot A to spot B. Okay, I like that, the way you're thinking. But now, let's go to the other great physics theory of the 20th century, the theory of relativity. One of its implications is that there is a maximum limit to the speed in the universe, which is the speed of light. From what we can see in the episode, teleportation takes place in a few seconds. The distance from the Earth to the Moon is 1.25 seconds. A few seconds, we would still be in the vicinity of the Earth, and that is not what we see in the episode. They would be violating the theory of relativity. Well, probably now is when you say that there might be additional dimensions and Graham is traveling through a shortcut in an extra dimension that places him from England to wherever in deep space Captain Jack Harkness is. Okay, I don't know if there are dimensions other than the 3 of space and the 1 of time. There are theories, though, that suggest that there is a total of 11 dimensions or even different numbers. Some suggest that there are 2 dimensions of time, one which of them is imaginary, Well, that is in the realm of not tested theories, and those dimensions would be different from the ones we experience every day. If you want to sleep well tonight and support the doctor, probably you could think that Graham is transported into a perpendicular dimensions and from there put back into a different point of our three-dimensional world. Okay, I guess. The second big weird thing that we see in this episode, spoiler alert, is that we have not one but two doctors.
Hello, I'm the doctor.
Well, that is not new. We have seen several episodes where the doctor meets himself, herself. The Day of the Doctor, Once Upon a Time,
Oh, dear.
The Five Doctors.
Fortunately, I do.
That's what happens with time travel. But in all those other episodes, the future doctors remember the old versions.
That is proper skinny. I've never seen it from the outside.
Which is not what happens in this one. Here, the two doctors claim they are younger versions, as they do not remember being the other. Well, that could just be a memory thing.
Regeneration, it's a lottery.
Oh,
But the other option is that the second doctor was coming from a different universe. Yes, I said from a different universe. Not that we know of or have detected other universes, but there are solid theories that would imply that there are. For example, the inflationary model. That was developed in the 1980s to explain some issues with observations in the universe. The model suggests that because of quantum fluctuations, the Big Bang took place not in a uniform way, and instead of one universe, there were created lots of universes, about 10 to the power of 500. Each one of these universes would be slightly different from others, or very different from others. In some of them, the laws of physics may not allow life as we know it. In some of them, there might be no stars. In some of them, there might be a very similar Earth with slightly different story. I wrote a science fiction novel thinking about this. Small world. Cosmologists and astronomers are looking for signatures in the cosmic microwave background radiations that confirm the inflationary model, which is widely accepted, although not by everyone. Well, if it is hard to find signatures of the inflationary model, how hard should it be to travel from one universe to another? I don't know. Another theory interpretation that presents multiple universes is the multiverse interpretation of quantum mechanics by EVERETT. The orthodox Copenhagen interpretation of quantum mechanics states that a quantum state that is in the superposition of two states is in both situations at once, up and down, right and left, black and white, at the same time. When we make a measurement of the quantum state, it collapses into one or the other. Only one of the options becomes true, and does that randomly. What the multiverse interpretation claims is that we can make a measurement, when we make a measurement, both options become true, but in different branches of the universe. The measurement splits the universe into two branches, one per option. Each branch can evolve differently. But again, we have no experimental observation of this, so if each doctor was coming from each branch, how hard should it be to travel from one to the other? I don't know, but may the science be with you.